Hi guys, so this is question 9 of our June 2022 past paper. Remember, this is a past paper. I have included all the questions in the description of this video. If you want to check all the questions from question 1 up until the last question of this paper, please check in the description. I have included everything. Anyways, let's solve this problem. We are given this function here, and you're told that the x-intercept of f are 3 and 0, m where it lies on the negative x-axis, right? There is m. And then k is the y-intercept of f. M and n are turning points of the function, right? So in the first question, we are asked to show that the equation of f is this one here. So this is what I need you guys to note, is that when you are having a turning point and it's also an x-intercept, this is how you write down the equation. So remember, as you see this equation, already the value of a is equals to 1, it's given. And then, yeah, we'll need to note that because before we get confused, right? So normally it's a into x minus x1, x minus x2, x minus x3, right? Normally it's like this for a cubic function, but because the x-intercepts share the turning point, so it's going to be f of x is equals to, and remember that a is equals to 1, so it's going to be 1 into x, what's the first intercept? It's 3, right? So it's minus 3, and then x minus x2 all squared. So when the turning point shares with the x-intercept, you just put the squared at the top there, right? And then now from here, you're going to substitute a point. The point that you're going to substitute is one of 0 and minus 3, right? So that is the k, right, which is the y-intercept, right? So we're going to substitute that, where there's f of x, you're going to put minus 3 is equals to, where there's x, you put 0. Like here, you put 0, so it's minus 3 into 0 minus x2, right, to the power 2. And then from here, it's minus 3 is equals to minus 3 into x, right, squared of 2. And then you divide by minus 3 both sides, minus 3 both sides, you have x squared is equals to 1, and then you put the square root both sides, x is equals to 1, plus or minus 1, by the way. So it's plus or minus 1, but we're going to take x being equals to 1. Why? Because here, chances are it's x equals to minus 1, so we have to take this positive 1 here, because it's not actually the x, it's not this value, it's this one here, x2. Remember that it's x2, so it needs to be positive so that when you take it to the other side, it becomes negative, right? So yeah, so that's how we find our equation. So meaning that we obviously now I know x2, this value here. So I'm just gonna erase this here, because we obviously not done like identifying the equation, right? So this is what we are going to do. So we're going to put in, okay, let me put the bracket here. So we're going to say f of x is equals to x minus 3. I'm sorry with the background noise. And as I said, x2 is 1, right? It's positive. It's going to be x plus 1, right? All squared like this, right? So now, now that we have this, so we can find the product, right? The product of this here is equals to, so I'm going to be x minus 3. So the product, you're going to find the product, we all know how to find the product, and I got x squared plus 2x plus 1, right? And then I'm going to find the product of everything here, which is f of x is equals to, so I'm going to multiply this x with every thing inside there. So I'm going to have x to the power of 3 plus 2x to the power of 2 plus x minus, so this minus 3 is going to multiply everything that is inside here, so it's going to be minus 3x squared minus 6x minus 3, right? So f of x is equals to x to the power of 3, so you collect the like terms, right? So x to the power of 3 minus x to the power of 2 minus 5x minus 3. So this is the equation of f of x. Let's check if it's the same as the one here. It's definitely the same, so meaning that we are done with 9.1 of this problem here. So now we are going to do 9.2. 9.2, we are asked to find the coordinates of n. What are the coordinates of n? N is the turning point of the cubic function, right? So meaning that we need to find the derivative of the function that we just got in the previous question, right? 9.1. So let's write it down. So the function f of x is equals to x to the power of 3 minus x to the power of 2 minus 5x minus 3, right? So the first derivative is equals to 3x squared minus 2x minus 5, right? So we always equate this to 0 when we find the turning points of the cubic function. So 0 is equals to 3x squared minus 2x minus 5, right? So you're going to factorize this, equate it to 0, so it's going to be 3x and x here, and then here we can put 5 and then 1 there, right? And the middle, the bigger number takes the sign of the middle term, so it's negative, and this would be positive like this, right? So, and then from here we're just going to equate. So 3x minus 5 is equal to 0, or x plus 1 is equal to 0. So 3x is equal to 5, or x is equal to minus 1, so x is equal to 5 over 3 here. So we have both solutions of x, right? But remember, we are asked to find the coordinates of n. So n definitely has to have an x value that is positive. So it's equals to 5 over 3, right? So now we have to find the y value. So we're just going to substitute in the original equation. What's the original equation? Original equation is f of x is equals to x cubed minus x squared minus 5x minus 3, right? So you're just going to substitute in the original equation. Substitute what? Substitute x is equal to 5 over 3. And you will get minus 256 over 27. So therefore the coordinates of n, let me just conclude. So therefore the coordinates of n will be, coordinates of n is going to be 5 over 3 and minus 256 over 27. So that is the solution for this problem here. So now let's go down to 9.3, right? But before we go to 9.3, let me erase this quickly. So I hope you guys are understanding this. I hope you understand calculus. I hope you're having fun. If you are facing any problems, let me know in the comment section below. Let me know in the comment section below. Sorry for speaking so fast. So yes, now we are going to do 9.3. For which values of x will, so it's 9.3.1, f of x be less than 0. So where is f of x less than 0? I mean, you just have to look at the diagram, right? Where f of x is less than 0. So f of x is greater than 0 from this point going upwards, right? But anything else is just less than 0. So you can use maybe from this point to this point and also this point, right? And going downwards, right? So what I mean by, isn't it to say f of x less than 0, right? Meaning the y values are less than 0. Here, at this point, y values are greater than 0, right? They're positive, they're greater than 0. But here, y values are less than 0. Hence, I'm indicating it like this. So, meaning you need to use your x values that you found in the previous questions. For example, here, x is equals to 3. Let me use a red color. X is equals to 3 here. And then here, x is equals to 5 over 3, right? And then here, remember the other x turning point. So x here is equals to minus 1. So you can use those x values to interpret this question, right? For f of x being less than 0. So you can say when x is less than 3, from this, when x is less than 3, then f of x is less than 0, which is true, right? Because the whole function is just less than 0 in this point. But obviously, it shouldn't be equals to. So you can just try to be specific and say x should not be equals to minus 1. Because here, that's the stationary point. That's where it stops, right? So it's not equals to minus 1, but it's definitely less than 3. So we are done with this small portion of the question. Let's go to 9.3.2. 9.3.2 says that where f is increasing from is increasing here, basically, and it's also increasing here. Here it's decreasing. So this is increase, decrease, increase, right? So how you can interpret it, you can use your turning points. I mean, from this turning point here of x equals to 1, you can say when x is less than minus 1, it is increasing. Or when x is greater than 5 over 3. When it's greater than 5 over 3, it's also increasing. So these two are your solutions for this problem here. So let me go down to another question. So another one says that values of x when f is concave up. So concave up means that when something is concave up, let's say a parabola is concave up, it means the value of a is greater than 0. It's a smiley face, right? The gradient is greater than 0. So for this instant, because we're talking of a cubic function with the equation of f of x is equals to x to the power of 3 minus x to the power of 2 minus 5x minus 3, right? So we have to find the second derivative and say it's greater than 0 because the gradient is greater than 0 since it's concave up. So we're going to say the first derivative of this is 3x squared minus 2x minus 5. And the second derivative of this is equals to 6x minus 2, right? And remember I said this f prime prime must be greater than 0 since it's a smiley face. So it's going to be 6x minus 2 is greater than 0. Transpose the 2 to the other side is 6x is greater than 2. And x is greater than 2 over 6, right? So therefore x is greater than 1 over 3. So this is the final answer for this problem here. So let's just erase and do another one. The last one, by the way. The last question, this is what you're going to do. Let's check it out. So the last question says that determine the maximum vertical distance between point F and F prime. The maximum distance equals to F minus F prime. That's what it means. So F minus F prime, the same between F and F prime. So first, let's find the difference between these two. F of x is x cubed minus x squared minus 5x minus 3, right? So it's like this, and then you subtract with the derivative, right? Derivative is 3x squared minus 2x minus 5, right? And the answer that you need to get once you subtract these two is x to the power of 3 minus 4x squared minus 3x plus 2, right? So now, to find the maximum vertical distance, you need to derive this d. So d prime is equals to 3x squared minus 8x minus 3, right? And we always equate this d to 0, so it's equals to 0. So then we factor out equals to 0, so it's going to be 3x and x, and then 3 here. Let me put 3 here. Let me put 3 here, and then 1 here. And then this would be negative, and this would be positive. So x is equals to negative 1 over 3, or x is equals to 3, right? And then we're going to take the x being equals to negative 1 over 3 to find the maximum point of this function here. So you're going to substitute this into your equation. This, you're going to substitute it here into this equation, right? To find the maximum. So the maximum that I found was equals to 68 over 27, right? So what I'm saying is substitute this x is equals to minus 1 over 3 in this equation here. You will get this answer here. Thank you so much for watching. If you're facing trouble in this video, let me know in the comment section below. Remember that this video consists of all the questions for this specific past paper of June of 2022. So check the description of this video to have access to all the other videos or the other questions that I've just done from question 1 up until question 10. You will find them in the description of this video. Thank you so much for watching. If you haven't subscribed, please do subscribe. Otherwise, take care.